All right, let's talk about something that every single Node.js developer has to deal with: files. You're going to be reading them, writing them, moving them around. But here's the catch. If you do it the wrong way, you can literally grind your entire server to a halt. So, in this explainer, we're going to dive deep and figure out how to handle file system I/O like a pro. The right way, the Node.js way. Let's jump in.
So this is the big question, right? Think about it. Let's say your server is buzzing along, handling hundreds of users, and then one person decides to upload a massive video file. If your code isn't smart about it, bam, everything just stops. Every other user is stuck looking at a loading spinner. The whole app is frozen. That's the nightmare scenario we're here to solve.
Okay, so here's our game plan. First, we'll get into the right mindset for Node. Then, we'll hit the basics, reading and writing files. After that, we'll look at managing directories. And finally, we'll get into the really cool stuff, Node.js streams. All right, section 1, the asynchronous mindset. And trust me, before we write a single line of code, we have to get this. This is the secret sauce that makes Node.js so powerful for I/O. It all comes down to being non-blocking.
And this slide just nails the difference. Think about synchronous or blocking code. It's like a single lane drive-through. You can't even start ordering until the person in front of you is paid, gotten their food, and driven off. It's a total bottleneck. Now, asynchronous, non-blocking, is way smarter. It's like a modern restaurant where they give you one of those little vibrating buzzers. You order, they hand you the buzzer, and you can go sit down, chat with friends, whatever. The kitchen is working on your meal, but they're also taking other orders. When your food's ready, bzz, the buzzer goes off. Your app is free to do other things, which is, well, it's everything for a server. And look, this isn't just my opinion. This is pretty much the golden rule. As the quote says, pretty much every Node developer worth their salt prefers the async way because it causes virtually no delay. If you want to build apps that can actually scale and handle real traffic, you have to think async. Seriously, blocking the main thread, it's like the #1 mistake you can make.
Okay, enough theory. Let's see what this looks like in actual code. We're diving into the bread and butter of I/O, reading and writing files.
So here it is in action. This is fs.readFile, our async hero. The key thing to notice is that last argument. It's a function. That's our callback. That's the restaurant buzzer. Node kicks off the file read and then just moves on. It doesn't wait. When the file is finally read, it triggers that callback function. And you'll see this pattern everywhere in older Node code. It's error first. The first thing you get in the callback is either an error or null, and the second thing is your data, the content of the file.
And now let's look at the dark side. Read file synchronous. See what's missing? No callback. Instead, it just returns the content right then and there. And that sounds simple, but remember what's happening behind the scenes. While it's reading, your entire app is just stopped, dead in the water. Nothing else is happening. You can probably see why this is a huge no-no for a web server.
And guess what? Writing files is the exact same story. You used fs.write, you give it some data, and you give it a callback. Node starts writing, your app keeps on chugging along, and when it's done, or if something blows up, that callback gets called. It's beautiful, isn't it? Simple, efficient, and non-blocking.
And of course, there's a file write sync as well. Same deal as before, it blocks. And what's worse, if there's an error, your whole program just crashes right there, unless you remember to wrap it in a try-catch. Like the source says, and I'll say it again, blocking the main thread is bad practice. The only time you might ever use this is maybe in a one-off script or right when your server is starting up before it's actually handling any users.
Okay, reading and writing? Check. But real-world apps are messier than that, right? We've got to create directories, check if we have permission to do things, and this is where some classic async traps are hiding. And that brings us to this beast, the race condition. This is a super common problem when you're working with async code. It's this simple, deadly pattern. You check for something, then you do something based on the result. But what if the world changes in that tiny little gap between your check and your action? That's the race.
Let me walk you through the classic trap. Step 1. Your code checks, hey, does this directory exist? Step 2. The check comes back and says, nope, not here. So you think, awesome, I'll create it. But, between your check and your create command, some other process swoops in and creates that exact same directory. So when your code finally tries to create it, boom, error. Your app might even crash. All because you lost the race.
So how do you avoid this? It's actually simpler than you think. You stop checking first. You just try to make the directory. Just call fs.mkkr. Then in your callback, you look for an error. If there is an error, and that error's code is exists, which literally means exists, then who cares? The directory is there, which is what we wanted anyway. We just ignore that specific error and we're golden. Any other error, well, that's a real problem we need to handle. That is the race condition-free way to do it.
And this idea kind of extends to checking permissions with fs.access. Now this one's a little bit different. With access, your callback only gets called with an error if something is wrong, like you don't have permission. If everything's fine, the error is null. So no error means you're good to go. You can check for existence, read, write, execute permissions. You can even combine them all into one check. Pretty handy.
Okay, we've covered the basics. Now it's time to level up. What do you do when you're not dealing with a tiny config file, but a massive gigabyte-sized video file, or a log file that's constantly growing? If you tried fs.readFile on that, you'd blow out your server's memory. This is where the pros use Node.js streams.
So, what the heck are streams? It's actually a pretty simple idea. Instead of trying to read the entire file into memory all at once, which is like trying to drink an entire swimming pool, streams let you work with the file piece by piece, in these small, manageable chunks. It's way more like sipping from a water fountain. This means your memory usage stays super low, even for huge files.
And if you want to see the most beautiful, elegant part of streams, look no further than .pipe. This one line of code is just amazing. You take something you can read from, a readable stream, and you literally .pipe it into something you can write to. That's it. Node takes care of everything else, breaking the data into chunks, making sure the writer can keep up with the reader, all the complicated stuff handled for you. It's by far the best way to copy a file or send data over a network.
Now, pipe is doing some magic, but it's not actually magic. You can do it all manually if you want to. What's really happening is you create a stream, and then you listen for events. Every time a new chunk of data is available, a data event fires. You grab that chunk, do something with it. When there are no more chunks, an end event fires. This gives you complete control to, say, parse a huge CSV file line by line without ever loading the whole thing into memory.
All right, let's just quickly run through the key takeaways here. Rule number 1, always prefer the async methods. Rule 2, get comfortable with that error-first callback pattern. Rule 3, to avoid race conditions, don't check, just do it, and handle the specific "it already exists" error. And finally, for big files, it's streams all the way, and your go-to tool for that should be .pipe.
So there you have it. You've got the toolkit, you understand the philosophy behind non-blocking I/O, and you've seen how to put it into practice to build really performant, really solid applications. You know how to avoid the common pitfalls and how to handle even massive files with ease. The only question left is, now that you know the right way to do it, what are you going to build?